So here's another example that uses a graph to find the limit instead of a calculator. So we're told that the function f of x is 1 divided by x minus 2 plus the number 3. And the graph of it looks like this. And it says in part 1 to find the limit as x approaches 3 on this function f of x. So in other terms, stand really close to 3 and tell me what the y-coordinate is going to be like. So there are two situations that could happen. You could be a little bit before 3 and you can be a little bit after 3. So I'm going to try to separate those. I'm going to put the 3 minus, which is a little bit before 3 by itself, and I'm going to calculate another limit as x approaches 3 plus, which is slightly after 3 on this function f of x, and my goal or my hope is that they will turn out to be the same number. So let's see. If I pick one of those yellow numbers like 2.99 or 2.98 and I look over to where the y-coordinate is, I'm going to see roughly speaking a 4. Okay, so that's great. We're done there. What about if I pick one of those blue guys? Again, you can pick them randomly. You can pick any whichever one you want, but no matter how you do it, once you hit the curve, turn around and look at the y-axis, and you'll see that the number is still a 4. So that's great and everything. That means that the left limit and the right limit were equal. So that's good, because that means that the limit as x approaches 3 without direction, without plus or minus, is going to be 4. So what does this result mean? What does it say? This result is saying that no matter which side you come from, whether your stick figure walks from left to right or right to left, as they get close to 3, they will be at the height of 4. Doesn't matter if they're coming left, right, or right, left. The answer is always going to be 4. So the final solution of the problem is actually that number right there at the end, 4. Now what about part 2? Part 2 says, again, find the limit as x approaches 2. So again, I'm going to do the same thing. I'm going to look for the 2 minus limit, and then I'm going to look for the limit as x approaches 2 plus. So I'm going to kind of like look at how the graph is behaving if I'm standing a little bit before 2, and how the graph is behaving if I'm standing a little bit after 2. So let's take a look. If I go a little bit before 2, and I stand on one of those yellow guys, where's the red curve? It's actually going down forever, meaning there's no y. Down forever means negative infinity. So this means the graph is going down forever. That's because of the arrow that we have, okay? Now what about the other limit when x is approaching 2 plus? If I pick one of those blue guys and look at the red line, what is the red curve doing? You'll see that again there's an arrow pointing up, which means that the graph is going up forever. So that's the reason why I put plus infinity. This means up forever. Now obviously, you don't need a genius to tell you that these two numbers are not equal, right? I mean, one of them is minus infinity, and one of them is a plus infinity. One of them is as big as it can get, one of them is as small as it can get. So from this result, what is the limit going to be when x is approaching 2? Well, the answer is no solution. It does not exist. DNE stands for does not exist. The limit as I approach to 2 does not exist. Meaning what? Meaning the numbers on the left and on the right are not agreeing with each other. They're not coming out to be the same, so I cannot decide what the middle number should be. Whereas over in the first problem, the number on the left, the number on the right were agreeing. They were both 4, so it made sense to say that the number in the middle should be also a 4.